Okay, the next topic is inverse functions. So in the box, I have the definition of an inverse function. This comes from your book, so I'm going to read through it really quickly. It says, suppose that f is a one-to-one function. Then, to each x in the domain of f, there is exactly one y in the range, because f is a function. And to each y in the range of f, there is exactly one x in the domain, because f is one-to-one. The correspondence from the range of f back to the domain of f is called the inverse function of f. The symbol f inverse is used to denote the inverse of f. Okay, this makes no sense, okay? If you're probably like, what does this mean, okay? So we're not going to rely on that definition. What I want you to think about if you're dealing with an inverse function is this little statement below the box. Okay, it says, think of the inverse of a function as the reverse of that function. So the inverse function undoes the operations that were done on the original function. Okay, so basically what an inverse function is, it is a function that undoes the operations of the original function. Okay, so I'm going to make something up really quick just to kind of illustrate what's going on here. Okay, so let me see. Let's say I have the function, let's see, let's do 3x plus 5. Okay, so a linear function here. This is a line. Okay, so what we're doing here, so say you were given the x value. Okay, follow the order of operations. The first thing you would do to that x value is multiply it by 3. Okay, so first thing we would do is multiply by 3. And then once we have that result, we add 5. Okay, this is what the original function does. Okay, so what the inverse function, and there's a way to calculate the inverse function. I'm just going to write it down here because I've done this for a long time. Okay, so the inverse function is going to undo these operations of the original function. Okay, so what the inverse function is going to do, it's going to take your x value, okay, and it's kind of going to undo these backwards. Okay, so instead of adding 5, it's going to subtract 5. Okay, so the inverse would first subtract 5 because that's the opposite of adding 5. Okay, and then to undo multiplication by 3, it's going to divide everything by 3. Okay, so that's how you want to think of an inverse function. It undoes the operations of the original function. Okay, and again, there is a technique for coming up with the equation of the inverse function. You do not have to eyeball it like I just did and come up with it on your own. There is a technique and we will go over that. But how I want you to think of an inverse function, it is the reverse of the original function. It's undoing the operations performed in the original function. Okay. All right, the next thing we have is some facts about a function and its inverse. Okay, there are 6 statements here and they are all very, very important for learning inverses. So we're going to go through them one by one here, and I'll talk a little bit about each. Some will make sense at this point and some may not, but after the completion of this lesson, you will understand all 6 of them. You'll see them illustrated in some fashion. Okay. All right. Very important. Number 1, the reason we've been talking about one-to-one, a function has to be one-to-one in order to have an inverse function. Okay. So if a function is not one-to-one, it cannot have an inverse. Okay. So a function must be one-to-one in order to have an inverse function. Okay. The next thing, this symbol f inverse is used to denote the inverse of f. Okay, do not confuse this symbol f inverse with 1 over f. Okay, the reason I say that, okay, you may have seen in another math class, which is true. If this is true, if you have a variable, not a function, okay, 1 over x, if you're dealing with a variable, this is equivalent to x to the negative 1 power. okay? So this is a function though, f is a function. This is not f to the negative 1 power, okay? If it is a variable you're dealing with, this is a true statement. 1 over x is the same thing as x to the negative 1 power, okay? But when you see a function and it looks like it's raised to the negative 1 power, that's not what's going on. It's a symbol, a notation for the inverse function of f, okay? So make sure you understand that. All right, number 3, ultra important, okay? This is kind of the whole idea that's going to help you find inverses, okay? Inverses, they undo each other. So if xy is a point on the graph of the original function, then yx is a point on the graph of the inverse function. Okay, so one more time. If xy is a point on the graph of the original function, then yx is a point on the graph of the inverse function. Okay, this is the heart of performing inverse functions. Okay, you are going to basically, you end up switching x and y. Okay, and I will talk more about that in a few minutes, but you need to remember that. Okay, xy will switch to yx. You're switching x and y. Okay, next, like I said, they're all important. All 6 of these facts are very important. Number 4, the graph of an inverse function is the reflection of the original function about the line y equals x. Okay, so what this is saying is, say you have the original function and you have its inverse and you graph them on the same grid, they would be reflections about each other, or reflections of each other about this line y equals x. Okay, so we will demonstrate this in lots of the examples that follow. Okay, but just keep that in mind. Okay, number 5, the domain and range of a function and its inverse are interchanged. Okay, very important. Okay, it comes back to this whole idea with inverses that you're going to switch x and y. Okay, so again, you'll see this illustrated in the examples, but what's going to happen here, this statement is telling me that the domain of f is going to be equivalent to the range of f inverse. And the range of f is going to be equivalent to the domain of f inverse. Okay, and that's true because you're switching x and y. Okay, all right, last thing. Okay, if you have a function f and its inverse, f inverse, the way you can verify that they are inverses of each other is this. Okay, if you compose them, okay, we did composition in the last section. Okay, and we know that the order of composition matters. You may not get the same thing. However, if you are dealing with a pair of inverse functions, if you do the composition in both directions, so if I do f inverse composed with f and then f composed with f inverse, you are going to get the same thing. And specifically, you are going to get x. Okay, so that is always true if you are dealing with a function and its inverse. These 6 facts are very, very important. Okay, like I said, throughout the examples in this section, you will see these concepts illustrated over and over. All right, let's take a look at example 3. Okay, all right, it said, if you look back at example 1b, we saw that the given function is 1 to 1. So we want to find the inverse of this function and then state the domain and the range of both the original function and the inverse function. Okay, so yeah, we did this a few minutes ago where we looked at this set of ordered pairs, okay, and realized, we made the arrow diagram and we realized that this is a 1-to-1 function. There was no sharing of y values. Okay, so what we're going to do now is find the inverse function and then give the domain and range of both the original and the inverse. Okay, so what I'm going to do here, I'm going to go ahead and call this f. That's the original function. Okay, It's a set of ordered pairs, okay? You can have that as a function. Doesn't have to be an equation. All right, I'm going to go ahead, before we deal with the inverse, I'm going to go ahead and state the domain and range of this particular function, okay? So remember how we did this. The domain is all the x values, and you're just listing them out. There are 5 different x values. When you list, you have to use braces, okay? So my domain is going to be 1, 2, 3, 4, and 5. And then the range is going to be all the y values. Again, there are 5 different y values. You list. You cannot use interval notation here. Okay, so we're going to get 2, 8, 18, 32, and 50. Okay. All right, so now we're going to write the inverse function. So again, the notation is F inverse. Okay, it is going to be a set of ordered pairs. Okay, and remember, the whole idea behind inverse functions is you switch x and y. Okay, so this first ordered pair 1, 2 is going to flip and become 2, 1. This guy is going to flip and become 8, 2. The third guy switches to 18, 3, and so on. So this will become 32, 4. And this last ordered pair, see if I can fit it, this will be 55. Okay, and all those ordered pairs go in braces. Okay, all right, so now the domain of F inverse is going to be all the x values for this function. Okay, so my x values are 2, 8, 18, 32, and 50. And all the y values will be the range of F inverse. So the y values here are 1, 2, 3, 4, and 5. Okay, and you can notice in this example, you see one of those properties, one of the facts about a function and its inverse highly illustrated here. Okay, the domain of F is the same thing as the range of F inverse. Okay, this was property number, let's see, number 5, that the domain and the range of a function and its inverse are interchanged. Okay, and also the range of F is the same as the domain of F inverse. Okay, they are equivalent. Okay, and the next thing we're going to do is talk about how to find the inverse of a function defined